Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be learning on the topic carbon and its compounds. And you're going to be looking at carbonates and hydrogen carbonates. So we're going to look at the reactions of carbonates and hydrogen carbonates with acids and the action of heat on carbonate and hydrogen carbonate. Some of these reactions, we did them when we were discussing on salts, so you can go back and check those videos. So we'll start with carbonate and hydrogen carbonates. Carbonates are sorts of metal ions or ammonium ions with carbonate ions. So the carbonate ions are obtained from carbonic acid when carbon dioxide dissolves in water. So you can see in the formula of carbonic acid, there is a carbonate ion and a hydrogen ion. So when the metal ion or ammonium ion completely displaces the hydrogen in carbonic acid, we form the metal carbonate or ammonium carbonate. So some naturally occurring carbonates are limestone. We're going to use limestone a lot in chemistry. We have malachite and dolomite. Hydrogen carbonates are usually derived from also carbonic acid in the same case, and they usually derived from the partial displacement of the hydrogen by a metal or ammonium radical. So when we were discussing on how carbonates are formed, we said it's displacing the whole of the hydrogen ions in carbonic acid, but for hydrogen carbonates, they are formed when the hydrogen ions are partially displaced. So for example, we have sodium hydrogen carbonate, potassium hydrogen carbonate, and ammonium hydrogen carbonate, which exist as solids. And then also we have calcium hydrogen carbonate and magnesium hydrogen carbonate. So these are the only carbonates that exist. Other hydrogen carbonate of other metals do not exist. So in our discussion, we are going to be focusing on sodium, potassium, ammonium hydrogen carbonate, calcium hydrogen carbonate, and magnesium hydrogen carbonate. So we'll start with the reaction of the carbonate and hydrogen carbonate with acid. So I'm going to put a stroke here because it's the same process that we are going to use also for the hydrogen carbonate. So hydrochloric acid reacts with the carbonates, and then one of the things you notice is effervescence or fizzing. So production of a colorless gas. This colorless gas goes through this tube and it goes to this test tube containing calcium hydroxide, and after a while you notice a white precipitate, which tells us the gas that is being formed is carbon dioxide gas. So when hydrochloric acid reacts with carbonate or hydrogen carbonate, a salt is produced and also carbon dioxide is produced. So let's go to the specific. When all carbonates and hydrogen carbonates react with acid, they give off carbon dioxide when reacted with acids. For example, if you look at the reaction of calcium carbonate with dilute hydrochloric acid, we are going to get calcium chloride and carbon dioxide and water. So the chemical equation is going to be calcium chloride, and this is a solid, plus hydrochloric acid to form calcium chloride, plus carbon dioxide gas, plus water liquid. So this is 2, let's not forget. Uh, this is calcium carbonate, not calcium chloride. Let's make that correction. So we balance the equation. So we have 1 calcium both sides. We have 1 carbon both sides. We have 3 oxygens both sides. The hydrogens are not balanced and the chlorine, so we have to put a 2 here and it's balanced. Zinc carbonate also reacts with dilute hydrochloric acid to form zinc chloride. Carbon 4 oxide, and water. So the equation is going to be zinc carbonate plus hydrochloric acid to form zinc chloride plus carbon 4 oxide plus water. The same manner, we are going to balance by putting a 2 here. And then when we look at now hydrogen carbonate, they will form the same product. So when we have sodium hydrogen carbonate and react it with hydrochloric acid, we are going to form sodium chloride plus carbon 4 oxide plus water. So that is sodium hydrogen carbonate. Remember, both sodium and hydrogen carbonate have a valency of 1, which reacts with hydrochloric acid is aqueous to form sodium chloride plus carbon 4 oxide plus water. So let's balance this equation. We have one sodium, one hydrogen, two hydrogens, one carbon, 3 oxygen, 3 oxygen. So you notice our hydrogens are more on the product side, so we need to balance them out. So when we look at our equation, it is already balanced. So everything is okay. You can see the sodiums are 1, 2 hydrogens. The hydrogens are the ones that we were contending, but as you can see, there are 2 hydrogens. Then lead carbonate reacts with nitric acid to form lead nitrate plus carbon 4 oxide plus water. So if we write this equation, it's going to be lead carbonate plus nitric acid to form lead nitrate plus carbon 4 oxide plus water. So we have one lead, one carbon both sides. So we have to put a 2 here to balance the hydrogens and the nitrate. Then finally, sodium carbonate plus dilute sulfuric acid will give us sodium sulfate plus carbon 4 oxide plus water. If we balance this, if we write the chemical equation for this equation is going to be sodium carbonate plus sulfuric acid to form sodium sulfate plus carbon 4 oxide plus water. Supposed to be the same, but water. So let's balance this equation. So sodiums are 2 both sides, carbon 1 both sides. The oxygens are 7. This side they are 4 plus 2 plus 1. So it is balanced. So the reaction between calcium carbonate and lead carbonate with dilute sulfuric acid does not go to completion. We mentioned this again when we were discussing salt. This is because of the formation of the insoluble calcium sulfate and lead sulfate, which stops the reaction. It forms a coating on the carbonate and then it makes it to stop. The reaction between lead carbonate and also hydrochloric acid behaves in the same manner. It causes the formation of insoluble lead 2 chloride, which coats the carbonates, stopping the reaction. When you look at now the action of heat on carbonates and hydrogen carbonates, this we have discussed also in salts. So carbonates are heated on a boiling tube, and then the gases are collected by passing them through calcium hydroxide, which is also lime water. So what you notice when you heat carbonates and hydrogen carbonates, one of the products that is given off is carbon dioxide, and the carbon dioxide is bubbled in calcium hydroxide, which turns into a white precipitate. If we were to heat sodium hydrogen carbonate, we would form some colorless liquid at the cooler parts of the test tube. This is because water is also produced. So all carbonates except the carbonates of potassium and sodium decompose when heated to produce metal oxide and carbon dioxide. So when you look at copper carbonate, for example, when you heat it, remember we said you have to show the heating sign. You form copper oxide plus carbon dioxide, which is balanced. This is solid. And then welded carbonate as well is heated. It forms lead oxide and carbon dioxide gas, which is balanced as well. Zinc carbonate in the same manner. When it's heated, it forms zinc oxide and carbon dioxide, and also calcium carbonate. When it's heated, it forms calcium oxide plus carbon dioxide. As for the ammonium carbonate, it decomposes when heated to form ammonia, carbon dioxide, and water. And we said ammonia is one of the basic gases. So if you put red litmus paper, it's going to turn to blue, and wet blue litmus paper is going to remain blue. So ammonium carbonate produces ammonia gas, carbon dioxide, and water as shown in the equation. As for the hydrogen carbonate, they usually decompose on heating to produce a carbonate, carbon dioxide, and water. So when you heat, for example, sodium hydrogen carbonate, you're going to produce sodium carbonate plus carbon dioxide plus water. If you balance this equation, you see we have two sodiums here. So if you put a 2 here, it's going to affect the amount of hydrogens, which balances out, the number of carbons, which are 2 this side, which balances out, and the number of oxygens, which balances out to 6 this side. So the same thing happens when you heat potassium hydrogen carbonate. It produces potassium carbonate. It does not decompose fully as well. This is solid, plus carbon dioxide plus water. If we balance it, we're going to put also a 2 here. So note this water is usually shown as some colorless droplets on the cooler part of the boiling tube, and it can be tested with anhydrous copper 2 sulfate or anhydrous cobalt 2 chloride. This is you. So if it is anhydrous copper 2 sulfate, it's going to change from white to blue. White is when it's anhydrous. When it's hydrated, it turns to blue. So calcium hydrogen carbonate. So when you heat it, you form calcium carbonate plus carbon dioxide plus water. So let's see our equation. So you notice our equation is balanced as well because we have two carbons this side. This is a 2 here. We have 6 oxygens and 6 oxygens this side. So when you continue heating this calcium hydrogen carbonate, you're going to decompose calcium carbonate further into calcium oxide and carbon dioxide. More carbon dioxide is going to be given off. So it decomposes further, unlike but sodium hydrogen carbonate and potassium hydrogen carbonate, which do not decompose further. So let's do a few questions in regards to what we have discussed. So describe the reactions of dilute sulfuric acid with carbonates and hydrogen carbonate. So dilute sulfuric acid reacts with carbonates and hydrogen carbonates to produce sulfate salt, carbon 4 oxide, and water, with the exception of calcium, barium, and lead, which forms an insoluble salt. Can continue and say insoluble sulfate that stops the reaction. Next, sodium hydrogen carbonate was strongly heated. Write the equation for the reaction. So sodium hydrogen carbonate, if you heat it, you're going to form sodium carbonate plus carbon 4 oxide plus water. And we said you balance it by putting a 2 here. And finally, without using any laboratory chemical, describe a simple experiment to distinguish between calcium hydrogen carbonate and sodium hydrogen carbonate. So we're not going to use any chemical, we're just going to heat the two solids separately in two boiling tubes strongly. So sodium hydrogen carbonate will decompose to give water, and sodium carbonate that do not decompose further, while calcium hydrogen carbonate will decompose to give water and carbon 4 oxide, but on continuous heating it forms calcium oxide and more carbon 4 oxide is given off. So that's the difference between the two. So that brings us to the end. See you in the next lesson.